had shared the same materials, but the only thing different in the materials that we had utilized is the battery. She began with making the 10 loops of the magnet wire, and she also connected the paper clips into the battery's positive and negative pole. She also had scraped the top right half of the wire and the top left half of the wire for it to be partially insulated and to be partially open for it to continuously spin around. Now, as you can see, she is making sure that the wire is scraped, and she is also making sure that the wire has a balanced weight from the other side to the other side, and she is also making sure that the wire is straight. And as you may notice, the magnet's quantity is 2 because that is the most effective quantity of the magnet to be used. And then you can see me here doing the same thing as she did because we did the task via Google Meet. Now in my case, I used a different type of battery, and fortunately it had successfully worked. And as you can see there, I tried to put it and it did a little spark, but yeah, successfully it worked.
Hi everyone, my name is Naran Aylin Nabilang from STEM Club Angel Gabriel under the Group 4. So let's start into the discussion. This experiment is related to topics such as electromagnetism, dipole forces, and electricity. But before anything else, let's talk about electric motor. So the basic principle for all working motor is the magnetic attraction and repulsion. The magnet will no longer move once it has attracted. As such, a motor needs some way to manipulate the magnetic field so that the magnet will continuously attract and repel. Alternating the direction of the current is one way to accomplish this. So, since AC electricity alternates, it naturally reverses the magnetic field with each change. So, take note that electromagnetism deals with electromagnetic radiation, or we can say that it is the phenomenon of the interaction of electric currents or fields and magnetic fields. So the next topic is the dipole-dipole force. Since in this experiment, negative and positive interact with each other, resulting in an attraction that manipulates the field so that the current will move continuously. Lastly is the conductors and insulator, which are also part of our motor. So since in a conductor, the outer electrons of the atoms are loosely bound and can freely move through the material when an electric charge is applied, while the insulator has a vital role in the spinning process since the wire is half insulated, resulting to the spinning motion that it creates. So yeah, that's it. That ends my presentation. I am now leaving you with the next reporter discussing about the significance of our motor and also some fun facts about physics. Bye!
Before answering the question, how does electric motor works, we need to know the things in our DC motor. First, the battery. It is the electricity provider. Second, the needle serves as the brush that connects to the battery. Third, the loop wire serves as the armature, and the end of the coil serves as the commutation for having an uninsulated and insulated area. Now, electric motor works because of the permanent magnet and the electromagnet in our loop wire from the charge of the battery creates a reaction of repelling. Furthermore, its spin continuously because of the commutation change the direction of the charge as well as the electromagnet from north to south spontaneously, and it concludes why the wire continuously spinning and answer the question how the electric motor work.
Physics has proven us that we could live life easier if we understand the concept of how things work, which is eventually helpful for the humanity. Like for example, generating energy into something useful. In this time of modernity, different machineries has been very helpful to do daily tasks and is considered one of the greatest creation of human. The project that we did in this quarter is a very helpful motor which are used in air compressors, lifts, elevators, winching machines, electric tractors, and even hair dryer and vacuum cleaners. This is the DC motor. A simple DC motor generates an electromagnetic field aligned with the center of the coil by using a stationary set of magnets in the stator and a coil of wire with a current running through it. To concentrate the magnetic field, one or more windings or insulated wires are wrapped around the motor's core. This type of motors turn electricity into motions by exploiting electromagnetic induction. In simple terms, it generates electricity which is helpful to our daily lives. The realization that I learned from this project is that we can really do something if we put our minds into it. Just like the original creator of the DC motor, who is a British scientist, William Sturgeon, in 1832, he invented a creation that became staple in the modern world. This project also taught us that patience is a key to success. Not all projects are successful at first try, and this helps us to realize the mistakes that we made and the lessons that we learned. Lastly, this project taught us that teamwork makes dream work. We cannot provide this meaningful video that you are watching right now without each and everyone's idea and contribution. That is all for my insight in this project.
As a student, I learned that electric motors impact almost every aspect of modern living. In our daily lives, electricity is used for a multitude of functions. It is used for lighting rooms, work fans, operate household appliances such as electric stoves, air conditions, and other variety of various appliances and devices to transform electrical energy into useful mechanical energy. In addition to running the commonplace appliances that we use every day, electric motors are also used in a variety of industrial activities. Nearly every possible product manufactured in modern factories uses electric motors at some point throughout the manufacturing process. Electric motors have a practically limitless variety of applications. Therefore, it's not surprising that there are approximately 700 million motors of various sizes in use around the world. Because of the quantity of electricity they consume, this massive number of motors and motor drives has a significant impact on the planet. In the past, the systems that regulated electric motors had poor performance, were inefficient, and were expensive. The demand for more performance and precision in electric motors, combined with the advancement of improved solid-state electronics and low-cost microprocessors, it has resulted in the development of modern adjustable speed drive in recent decades, which, by the way, an ASD can be thought of as electrical control devices that change the operating speed of a motor. ASDs are able to vary the operating speed of the motor by changing the electrical frequency into the motor. That's all the insights that I had in mind with regards to the significance of building electric motor, which I think is an eye-opener in the world of electronics.